So, welcome to the video lecture series of Fourier transform. Today, in this video, I will discuss about the convolution of signal. Basically, for having the convolution using Fourier transform, you have to perform the convolution between two signals. As you have seen, that here x1 is given by e to the power minus 2 ut, x2 e to the power minus 3 ut. So two function or two signals are given here. So what would be the procedure? As we know from the property of Fourier transform is that if you need to perform the convolution of two time domain signal, you need to have the Fourier transform of themselves. That means the Fourier transform of x2 is given by x omega and the Fourier transform of x2 is x2 omega. So if you after having the Fourier transform of both signal, when you multiply both of them, ultimately you will get the convolution of two signal. So in case of inverse Fourier transform, nothing but after multiplication of two given after multiplication of two Fourier transform of two given signal, then you can when you will take the inverse Fourier transform, you will ultimately get the convolution of two signal. Basically, these are two same. These two are same. So in that example, we are given two signal x1 and x2 as like that. So we need to convert. We need to determine the convolution of those. So using these properties, first of all, our first target would be the determination of the Fourier transform of each signal. So the Fourier transform of x1 t is x1 omega is 1 divided by j omega plus 2, because we know the Fourier transform e to the power minus a t ut is 1 divided by a plus j omega, as we have discussed and we have seen several times in this lecture series. So this is the Fourier transform of x1 t, and this is the Fourier transform of x2 t. So using these properties of Fourier transform, we need to multiply and we finally get the convolution of two given signal x1 t and x2 t. So this after that multiplication in the similar fashion as we have discussed in the previous video, that how should we implement the partial fraction depending on the denominator and numerator of the given function. So seeing this, we need to formulate the partial fraction as like that, as follows. So AB fashion, and after determining how and I also discussed in previous videos how to determine the value of a and b. I want to mention again here, just need to multiply both sides by the denominator of the left side. So we need to multiply that side and that side by j omega 2 into j omega plus 3, and after that separating the real and imaginary part, actually we will get the value of a and b. So after putting the value of a and b, basically you need to take the inverse Fourier transform of them, and then you will get the Fourier transform in time domain of the given signal. So your ultimate goal was to determine the convolution of two signal, and by using the Fourier transform technique, you actually able to determine the convolution. So you are given two time domain signal, and finally you will get the time domain signal. So this actually represent the convolution of two. So the process is that first of all you need to determine the Fourier transform of both given signals, then you need to multiply both of them, then after processing a partial fraction or something like that, you need to transform, you need to take the inverse Fourier transform of that signal. So in this in that case we need to perform the partial fraction. In many cases it may not be useful or it may not be required. However, in that particular case, partial fraction is needed. So after having the partial fraction and having the value of constant, we will able to take the inverse Fourier transform of that signal, and ultimate destination was to have the convolution of that signal. I think it would be very helpful. This is the easiest procedure to have the convolution of a two given signal. So this is the as I discussed in the first lecture or first slide, that what are the importance or merits of Fourier transform is that if you by using the Fourier transform you can perform the convolution of any two time domain signals. So this is the most important characteristics or important thing regarding the Fourier transform. I hope it would be very helpful for you. If I think another example, if we discuss two given about to determine the convolution of two following signal x1t and x2t, then first of all we need to transform it to Fourier. We need to determine the Fourier transform of both signals respectively. Here x1 omega for x1t and x2 omega for x2t. So t to the power minus ut. So we know actually the Fourier transform of that particular signal. We have discussed in several times in this lecture series. So and also I will request to check the basic properties or basic Fourier transform laws, where you can find that what would be the Fourier transform of a signal like that. So the Fourier transform of that is that, and for this it would be that, and our next target is to determine the convolution and ultimately the multiplication of two of them. So after having the multiplication we will get that, and to have the convolution we need to take the inverse Fourier transform. So what would be the inverse Fourier transform? Actually we need to separate, or we need to go through the process of partial fraction. So for the partial fraction, this fashion we should have to perform A, B, C, D, because we have the four roots. So for this similar root we need to perform like that, j omega plus 1, j omega plus 1 square, like that. In previous slide, in previous lecture I have discussed, please check that. So in this way, as I have said that you should multiply the denominator of left side in both should be multiplied in both sides. So after multiplying that you will get like that, and considering j omega is minus 1 as we discussed in previous. So j omega is minus 1, j omega is minus 2. When we put j omega is minus 1, we will get b is equal to 1. When you put the j omega is minus 2, because where we will get the we think why do we think we need to place j omega is minus 1, because j omega is minus 1 is one of the root of this equation. So so j omega is equal minus 1 has been written there, and for getting the value of b, for the j omega is minus 2 we will get the value of d, and if we put the value of b and d, our next equation will be like that, and still the value of a and c are unknown to us. So again we need to separate the real and imaginary part, as you should check step by step. I have written here. So to do so we again need to perform the real and imaginary part, and in this way after solving two equation we will get, after when we separate the real and imaginary part, actually at first we will get this equation, and after again having the rest of the equation we again separate the real and imaginary part, then we will get the another equation. After solving two equation, we will get the value of c. This is a complex task actually. However, in the examination, basically there will have a sort of example or question that you can solve, or you can maintain the proper timing. So nothing would be difficult, and I will request to you, don't be what should I say, don't be hesitated, or don't face any difficulties in this way. So just this is the procedure I want to mention, and in this way sometimes you need to solve this. So I hope you will be able to understand and to determine, and you will able to determine the value of constant. So in this simple procedure, you will able to determine the constant value of constant, and after putting those, you need to take the inverse transform, Fourier transform. So as we know, the inverse Fourier, as you know, the Fourier transform of e to the power 1 divided by a plus j omega, many of time I have used and in this lecture series. So it would be very easier for you to transform this, and ultimately you will get the xt. So what would be the significance of xt? Xt basically the convolution of two given signal, as we are being asked. So this is the procedure. So at the end, I will request you to practice more. Actually, if you in this Fourier transform, actually would be very easier for you if you grab the properties as well as the basic transformation. So it would be very easier for you if you practice those. Otherwise, it would be so difficult for you. So I tried to incorporate all the example, at least one and several, and I in many time I said to you that always I try to present anything in convenient way. If you have any question and query, please ask me in any way.